Hello, hello, beautiful people. Welcome to 11.2, Multiplying and Dividing Rational Expressions. So for your warm-up, I'm going to have you go ahead and press pause if you have not done so already, and go ahead and do this wonderful, wonderful warm-up that I have prepared for you. Thank you. And thank you for pressing unpause. I'm going to trust that you did. Number 1 was 1/9. Number 2 was also 1/9. Main thing I want to remind you of is that when you are dividing, and this is the division sign, you do need to multiply by the reciprocal, so 1/6. And then for number 3, it's a review from 11.1 that you just watched. Let's see if you did it on your own. We factored first, canceled and canceled, then I got -4 over t plus 1. And then my restricted values were t cannot be -1 and t cannot be 3. Beautiful. Okay, let's go on to today's lesson though. We're going to use what we did for numbers 1 and 2 as well as a little bit of number 3 to help us find the product of each of these. Find the product. So for number 1, typically I don't cross cancel variables like how there's some x's all over the place. I like to save those for last, but I can cross cancel numbers if possible. So what I mean by that is that I'm looking at 3 and 9 and I'm asking myself, what is the biggest number, Miss Fitzgerald, that goes into 3 and 9? And I come up with 3. 3 goes into 3 one time. 3 goes into 9 3 times as well. 3 goes into 3 one time. 3 goes into 9 3 times. And then what's the common factor? The greatest common factor for 14 and 28? 7 is a factor of both of these. So is 2. But the biggest one that goes into 14, 28, you guessed it, 14. 14 goes into 14 one whole time. 14 goes into 28 2 times. Let's look at what's left. 1 times 3 is 3 up top. And then I still have that x to the 5th power. And then I have 1 times 2, that's 2, dealing with the numbers first. And then x squared times x to the 8th power. Remember, when I'm multiplying and they have the same base, I add the exponents. That gives me x to the 8th power. Now, previously when we've done this, most of the time the bigger exponent was on top, but this time it's not. Here's how this works. I'm looking at x to the 5th and x to the 8th. How many x's can I take out of both of them? How many x's can I take out of both of them? Well, this one has 5 and this one has 8. So for this one, I'm going to take out the smallest number possible, technically, or the biggest number possible, which would be 5. I can take 5 x's out of here, and what's left? Nothing. And if I take 5 x's out of here, 5, take 8, take away 5, I'm going to have 3 left. So I already have that 3, and I have the 2, and then all my x's were gone up top, but on the bottom, I still have 3 left over. We had 5 and we had 8. We took 5 off of both of them, and all I'm left with is 3x cubed. Bueno. Next, for number 2, beautiful people, what I would like to do here is factor first. I know we have x's all over the place. We've got, 15, 25. Don't fall for that trick. Your first thing that you need to do is to factor first. And I'm going to tell you now, because this is not that video. If you are struggling with factoring, you need to see me or watch one of our previous lessons where we learned factoring. But for now, today, I'm going to have you mostly trust me. So I'm looking at this numerator, and what goes into 2 and 6? 2. What's left? X minus 3. How do I know I'm right? Because if I multiply 2 times 3, I get 2 times x. I get 2x, and 2 times 3, I get -6. On the bottom, this is a special pattern. This is like the same one that I've been talking to you all about. A plus b, a minus b. Difference of 2 squares, 2 perfect squares, gives me x plus 5, x minus 5. While I'm in a wonderful place here, this is also a special pattern. It's difference of 2 squares as well. Sorry, that was the rule I was referring to. My bad. This will be 2 terms, 2 perfect squares, 2 sets of parentheses, x and x. 9 is a perfect square. It's 3 and 3. Now for this, you can use a box. I think I'm going to use this this one to show you, well, no, you're going to trust me. Factoring using a box, you would have x minus 3 times x plus 2. Just kidding, plus 5. I'm doing that in my head, and you're going to need to trust me a little bit that it's correct. I'll show you a review of the box in just a little bit, but for now, trust. Okay, now cross-canceling the same way that we did for number 1 by terms. This has an x minus 3 and an x minus 3. I can't do these because they're both up top, but this x minus 3 can cancel with this x minus 3. I could have also just canceled this one and this one, but I can't cancel both. Just one set here and one set here. What else can you find that we can cancel out? Okay, I see I made a mistake. In my factoring where I told you to trust me, this would be plus 3 and minus 5. Yeah, that's embarrassing. Bet you I lost all your trust right there. And then, so now I can also cancel out the x minus 5 and the x minus 5, and the x plus 3 and the x plus 3. What's left up top is a 2. What's left in the bottom, the denominator, is x plus 5. Okay, I'm going to regain your trust back. I promise. I promise I'll get it back. Okay, let's look at this. Number 3, divide. Find the quotient. And I am given 3x over x minus 2 divided by 4x to the 5th over x minus 2. So remember, the rule for dividing is you have to multiply by the reciprocal. So the first one will stay the same, and then I will multiply by the reciprocal. So we're going to do the old switcheroo and put x minus 2 up top and 4x to the 5th on the bottom. Just flipping it. Now, there's nothing for me to cancel, which is great, but I can cancel those out. Nothing for me to factor, excuse me. I'm going to cancel out x minus 2 and x minus 2. And I can cancel out with 3 and 4. So what's left? 3 over 4x to the 5th. Final answer. Not too much different from what we did in 11.1, where we just need to factor and cancel, factor and cancel, factor and cancel. So that's your answer for number 3. Number 4, notice you have a little bit of extra space there to the right of this problem, so you can use that as well. I'm looking at this term, this box right here, this expression, and as I was saying, if you scoot your paper over a little bit, you get a lot of clear space, a lot of blank space there. So I was looking at 2x squared minus 9x plus 9. And I'm going to use a box because I messed up the last time when I didn't. Got a little too confident. Like, oh yeah, I do this in my head. I messed up. First term, first box. Last term, last box. Great. Now I'm looking for two numbers that will multiply to give me 18x squared, this product, 2x squared times 9, and that will add to give me negative 9x. So both of the terms should be negative. Why? Because I need to multiply two negatives to get a positive and add the two negatives to get a negative 9x there on the bottom. And what would those two numbers be? I don't know. 6 and 3? 6x and 3x? Multiply negative 3 and negative 6, I get positive 18. And if I add them, I get negative 9x. But you can't see me. There we go. Sorry about that. My apologies. Multiply to give you 18x squared and add to give you negative 9x. So I'm going to put those two numbers in my diagonals, and I'm going to factor. So what goes into both of these two terms? Just an x. What do these two terms have in common? 3, but I'm going to use a negative because I'm always going to take the sign that's closest to these edges. 2x squared and negative 6x both have a 2x in common. Negative 3x and 9 both have negative 3 in common. Sign closest to the edge. So that factored to 2x minus 3 and x minus 3. Perfect. So that's this portion right here. 2x minus 3, my apologies, and x minus 3. Now this denominator, not so bad. What goes into 35 and 14, you might ask? 7. What's left? Well, what's this divided by 7? 5x plus 2. because 7 goes into 14 2 times. Now, I need to do a little more factoring. I'm going to leave this as division for a moment. And we do have a problem. I'm going to factor out a -1 first. -1. What's left? Why? Because the factor box doesn't work if if the leading coefficient is not a positive number. So I'm factoring out -1, and what's left is 3x squared minus 13x plus 12. Basically, I'm changing all of these signs. And then you can use a handy dandy factor box. I remember that was a -1 up front. And then I had 3x squared minus 13x plus 12. First term, first box. Last term, last box. I'm looking for two numbers that multiply to give me 3 times 12, 36x squared, and that will add to give me -13x. Can you think about those numbers for a moment? Go ahead, press pause if you want some think time on that. But they need to multiply to give me 36x squared and add to give me -13. I'm thinking -9x and -4x for my diagonals. -9x, -4x. So what do these two have in common? Just an x. These two, -3. These two terms have a 3x in common. And here I'm going to factor out a -4. So what am I doing with this? Well, remember we had the negative sign here. And then we had x minus 3. And we had, along this side right here, 3x minus 4. Okay, now that I have proven that I can factor, perhaps now you can trust me here. This denominator, I'm going to color code that for us. This denominator factors 2 using the box the same way that we just did. 3x minus 4 times 5x plus 2. Go ahead, press pause right now. Prove it to yourself. Use a box right now to factor that term. Okay, so I'm good. This is 2x minus 3, x minus 3 over 7 times 5x plus 2. Now when I divide, I multiply by the reciprocal. So now this, which was in the denominator, comes up onto my numerator, and then this will go down. So negative x minus 3 times 3x minus 4. Cross cancel as much as we can. So first thing my eye goes to is this x minus 3, x minus 3. Gone. 5x plus 2, 5x plus 2. Gone. Anything else, guys? Good eye. 3x minus 4, 3x minus 4. What's left up top? Well, 2x minus 3 I see up here, and I see a 7, and I see a negative sign right there. That's it. However, some people hate this, or you can put the negative out front because having a negative in the denominator is a little bit low-key weird. That's also acceptable. There's another or, but I think these are the most common ones that you will see. Just making sure that you put a space between this, and then you're golden. This or this. Okay. There you go. Again, if you struggle with boxes, go ahead and create one for this last term and the last corner that you have here. And just make sure you put the first term, 15x squared, and your last term there, and you're looking for two numbers that multiply to give you this product and add to give you the -14x. All right, thank you so much for joining me, and have a delightful